Hello there and welcome to part 2 of the GraphQL series. And today we are going to talk about mutations and how you can exploit them or you can test them. But before we jump into that, first I want to explore how you can test the application when introspection is disabled or when you cannot get the schema out of the GraphQL API. So Zad reminded me of that. I totally forgot to mention it in the first part. So let's have a look at that. Here I have my application and my burp suite running. The first approach that I'm always going to enforce. So let me turn on my inspect. And when you do that, start clicking on every element you see in the application and analyze every traffic in the network tab. For example, if I click on create new post, you can see a GraphQL request is going here and you can see all post is a query and there are a number of fields that are passing by. And in the response, you can see there are a number of posts. In this case, there is only one element here. I cannot click on this because this is disabled right now. And if you don't want this bunch of rubbish data, you can just click on fetch XHR. So it's only going to show you the GraphQL request that is happening. So again, it depends on the complexity of the application and your patience, because that is very important when you're bug hunting. So you have to analyze everything, and once you find out different kind of queries and mutation, you can send those requests to your burp suite in the repeater, and you can start testing for different vulnerabilities such as DOS or batching attack, IDOR or mass assignment. I have covered some of this vulnerability and also CSRF in the previous GraphQL videos. You can check them out. The second approach I want to mention is actually a tool. So the tool name is Clairvoyance. So you can find it on GitHub. I think that was the spelling. Yeah. So this is the tool and you can find it on GitHub. Install it using the pip commands. So syntax is Clairvoyance, and then you have to provide the GraphQL endpoint and then the output file, that is in this case schema.json. Now what this tool does, it is try to reconstruct the schema for you by analyzing the GraphQL response. For example, it uses multiple words from a particular word list and then it checks if the GraphQL responds by giving some error hints. For example, you might have seen such cases if you have written a wrong query or mutation. The GraphQL respond in a way and it says, did you mean dash 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 query or mutation? So based on that hints, this tool try to reconstruct the whole thing. I'm going to tap the command and then I have to provide the GraphQL API, which is in this case is here, and then -o for schema.json. Hit enter. It's going to take a minute or something depending on how big the GraphQL schema is. In this case, it shouldn't be taking so much time. So I would want to suggest that, let's say you have found a GraphQL application, run this tool in the background and then start analyzing the application manually as well. This way you can save time and see if it is working or not. But let me give you a reality check. This tool is nice, but it might not work all the time because not all the application enable that hinting thing either. They even disable it. Sorry, but this is how I like mentioning things. I don't want to tell you, oh, this is a magical tool and now everything will work out. It's more about patience. So you can see it is going through some iterations. It's similar to what you do in directory brute forcing or file path brute forcing. You try a number of word lists and see what's working, what kind of response you're getting, and based on that, you find which one is legit. Okay, the blind introspection is finally completed. Let's open up the schema.json file. Okay, and now we have the whole schema here. So I want to show you something how it actually constructed this for better understanding. Let's say I have this query. Now this works fine, but if we add something like all post, Now this is a wrong one, it doesn't exist. And in the response we are getting, cannot query field all post on type query. Did you mean all posts? So this is giving us a hint, and this is how this tool found all the original queries, mutations, and objects. So now you have a visual view of this. Now once you have this schema.json file, you can copy it and paste it in GraphQL Voyager that I mentioned in the previous video. That gives you a visual view of the objects and fields, which is amazing. Okay, now let's move to the mutation thing. From the previous video, we saw that only queries were enabled and we didn't see any mutations. So if I open the docs now, you can see the mutation is added here. And if I click on the mutation, there is one mutation, create post, which take input title, body, and author ID. And then it can also fetch some data for you from the post object. So for example, if you have created a post and then you want like a body, author ID, or title in return after you have created the post, it will return it for you. So let's type the mutation here. This is a mutation. I hope you can see it. So you can see in the input we have provided 3 fields. Body, this is the test post. Title, I'm going to type Medusa title. I think author ID should be provided by the server and it shouldn't be writing your own author ID here. That's weird, but let's say 4 and send the request. Now in the response, we have the data submitted. Okay, this is how mutation work. You're just creating, updating, or adding data to the database, similar to post HTTP method. Now, what could be the problem here? From what we have analyzed earlier, we need to find all kinds of fields. That's why I said analyze the application to see all kinds of mutation and queries and what fields are they expecting. If there is a field that shouldn't be there or that shouldn't be set by the client side, like the author ID, then it could be a potential vulnerability. Let's try fetching all the posts. So here we have the post and the author ID is 1 here. So this is the author that posted this post, and this is by author 2, and this is by author ID 2 again. And then this is me with the author ID 4. Now, each author ID identifies a particular user. So every user has a different author ID because that is the only author of that particular post, and someone should not be able to make a post based on different author IDs, right? That sounds like an access control issue. So it's like I'm making post behalf of a different author. And that's why I shouldn't be able to set the author ID by myself. Let's try to create a post with author ID 1. So now I'm going to change the author ID to 1. And I just added some random data. Now if I click on this, the post is created and the author ID is 1. This shouldn't be happening because the author ID belongs to another user, and now I have created another post by a different author. Now if I again try to fetch all the posts, you can see that it is added here. There should be some access controls. Actually, the field shouldn't be present here in the first place. They should just remove the author ID field, and that should be set by the server only, not by the client side. And that's why I said explore the GraphQL manually, because this is something you cannot analyze through automation tools, and that's why it's important to spend the time on the application. The next vulnerability we are going to talk about is IDOR in GraphQL. So now we have the Docker file here running for the IDOR. If you open this up, you'll actually be presented with a login page. You can log in if you want, but you can directly move on to the GraphQL endpoint. And one thing I noticed is that when you click on the query, you see another query here that is single user. This was not present in the previous Docker files, but now it's here. So you can see that the single user expects a user and its value is an integer. So I guess it's like a user ID. If I click on the single user, you can see over here, and if you click on the user info object, it returns fields such as UUID, name, surname, date of birth, API key, user, and then ID. Okay, so from this information, we got to know that the user is expecting a number or integer value. So if we construct this query here, we can see the response, and it gives us the API key of another user, which is John Doe. Let's try to change the user ID to 2. And here we can see the value of another user. So here we have the IDOR, where the user ID is not being checked in the server side, and it reveals information in the response. Moving on to the next vulnerability is SQL injection in GraphQL. So I have run my Docker file again for that, and now we have 2 more queries in the docs, as you can see. First is SQL up, which expects IP as a string value, and then we have get user, which expects username as an argument, and you have to provide the username, and it will return some values in the response, such as the username, UUID, and is admin. So let's construct the query for this. Don't want to waste your time, so I just pasted the query here. In the response, we can see that we have got the ID, username, and is admin value, and we have provided the username John Doe. So this is how this query is normally supposed to work. Now, when you're testing for SQL injection, you do what you normally do in a normal web application. You find a potential parameter, and then you try to add a single quote to it to check if there is some response like a syntax error. And similar to that, we got here a syntax error. As you can see in the response, it says select users.uid, users.username, and users.password, and users.admin, where username equals John Doe from the users table. So based on this response, we can figure out that a users table exists, and these are the column that is user ID, username, and is admin, and password. So we can try fetching these. Let's type password here and remove the code. Let's see if we can fetch the password for John Doe. And we cannot. It cannot query the field password on type user object. Okay, means there is some kind of exclusion here. Another thing we can try here is this syntax. You must have seen this syntax before, obviously, because this is the most basic. You try to close the original syntax of the SQL, and then you inject your own, that is or 1 equals 1. Now 1 equals 1 is true, so it gives a true condition, and that's why it executes our query without any error. And again, we can see some values in the response. So this confirms that this GraphQL is vulnerable to SQL injection. Our motive is to fetch the password of the user, because we cannot fetch it from here by providing it in the fields. So to do that, we can use the union select to select some of the columns and try to fetch their values. If you have no idea what union select query is, I would suggest you go solve SQL Labs. Okay, so here we have the syntax for the syntax to fetch the username UUID from the users table, where is admin equals true, means we want to fetch the user who is the admin. Okay, let's run this, and here we can see this is the ID and username. So username is admin, so this user is the admin of the application. Now we cannot do much with it because we don't know the password of the admin. That's why we have to fetch the password, but I wanted to show you how the union select queries are working here. If we type the password, let's see if we get any response though. No, we don't. So this is happening because of the logic in the backend code. So the author has provided here, as you can see, this user object class, here you can see exclude fields, and it contains password field. So this hides the password in the query for users. So even though it exists, it's going to exclude it in the response of the GraphQL. In this case, how we are going to fetch the password? We can do that by using a trick. Now, it can sound a little confusing, but keep listening. So when you use a union select query, you basically inject your own fake row and you say, okay, select the username, UUID username, and from the users table and show me the values. So it creates a fake row and then it fetches the value of the ID and username and give it back to you. Now, it's not selecting the password field and not showing the password field in the response, but one thing we can do is we can try to get the password value in the other column. For example, we can get the password value in the user column. For that, we can type a query something like this: union select password, 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 because there are 4 columns from the users table where username is John Doe, and then comment out the rest of the thing. So what we are saying that select the password value and display it in the ID or username field, because these 2 fields are allowed and we can see the values of these 2 fields. These are not excluded as we saw in the backend code. So we can extract the value in these columns instead. If I run this, you can see the username is now giving the password value because we wanted the password value to be in this particular column. So this is kind of like a trick that you can try. So even though the password is excluded, you stuffed its value into the ID or username or any other fields that are allowed in the schema. Okay, if what I said is true, then you must be wondering, then why ID field is not containing the password? I mean, I'm saying just to add all the password in any column that is accessible, and ID is also accessible. Then what is this value? Actually, this is also the password, but it is base 64 encoded because GraphQL is base 64 encoding the value in the ID. So the password just got automatically base 64 encoded. If I copy it and go to terminal, and here I do echo base 64D, you can see that it says password 1. So yes, it is working, and you can try this anywhere where you see if a field is not returning the value that you want to get. You can just get it in another column. Moving on to the next vulnerability we are going to test is OS command injection. So in the query, we had 2 new queries and we already tested the get user. The second one is SQL up. So this is a simple query and it expects argument IP and it takes the IP value here. So let's type it out and see how it responds. Okay, so I have the query here and this is the IP. Let's run this. It says not enough values to unpack, expected to go on. Okay, I think it's also expecting port number. So let's give port 5000 because that's what the application is running on. Seems like it's working fine now, but it's taking some seconds to get the response. Now we have the response. Okay, so to test for OS command injection, we can try something like this. Who am I? This will add our another command, who am I? And let's see if we get any response. Okay, we got the response, but we don't see anything here. Seems like it is blind SQL injection because we're not seeing any response. Also, there could be no injection at all, but it is good to try some time-based payloads as well in this case, so we can confirm. So I'm going to say sleep and 5 seconds. Run. It is better to test this thing out in Burp Suite actually because it shows you the response time as well. But yeah, we can manage that here. It sure seemed like it took its time. Let's increase it to 10 seconds. Okay, it is definitely working because now it's taking more time. So it is blind OS injection here. So to test for blind OS injection, you can use the OAST method, which is out of band security testing, in which you use some kind of service to get the log interactions. So basically, you're going to host your own server, like by using Interact SH Client or Burp Collaborator, and you can get the response back in there. Okay, so let's type some commands that are going to help us out. For that, we first need to get something where we can log our interactions, right? For that, you can use Interact SH Client. So here I have the Interact SH Client. I also have the tool installed in my terminal, but it is giving error. I don't know why, but I have to solve it. But right now, the web version will do. So let's copy this thing and then type ns lookup, and then this. Okay, run the query. And seems like it worked. Let's go to the client and we can see we got some DNS hitbacks. Okay, now we can try adding some commands. For that, we can type in brackets and who am I. Assuming that this is a Linux system, we are typing this command and then dot. So it's going to fetch the who am I value and just replace it in the DNS response we get. Let's run this. Okay, let's move to the client, and here we got some interaction, and you can see it says root means the who am I command did give us a response. Okay guys, you can try some of the more commands here and play around with it. I want to know what kind of commands you tried and which one gave you a really interesting response. So do let me know in the comment section. That's it for this video. I hope you enjoyed watching this, and I end the second part. Also, let me know if there are any topics you want me to cover in my future videos, and don't tell me malware analysis, because my channel is more about the web and APIs. So keep that in mind and let me know your views. See ya.